Welcome to Activity 2.3, Forces that Act at a Distance. So the force between the Earth and other objects is different from contact forces. So far we've learned about forces. For example, when we drew the model of you sitting on your chair. You're pushing down on your chair and your chair is pushing back on you. Those are contact forces because you're in contact with the chair. Now there does not need to be contact between the Earth and other objects for there to be a force between them. For example, skydivers are pulled down because of their weight. Leaves fall because of their weight. Rain comes down because the Earth pulls it down. People in an airplane have weight. So in these cases, the objects being pulled down by the Earth are not in contact with it. Since gravity is felt whether or not you are in contact with the Earth, the reason for the force is non-contact or not contact. So gravity is called a force that acts at a distance. Magnetic force is another example, and electrical forces is another example. So forces that act at a distance are forces that act on an object without there being contact. So that's going to be the focus of today's lesson. Now, if you are watching this video, it means you probably were absent or you need to do this for another reason. So you won't see this demonstration. But one of the things that I've done, or that I did in class, is I took an inflated balloon, and you could rub it on your hair. I just rubbed it on my shirt, and then bring it near some small pieces of paper. One of the things you'll notice is that there's an electrical force that will either attract or repel the paper to the balloon or the balloon to the paper. So what I did in class was I did that, and I had some paper punches out of the copying machines, and you would have been able to see that the balloon actually picked up these pieces and that they stood on end. And even though they were sometimes 2 or 3 inches away, the paper still would do that. The paper would jump up towards the balloon. It would stand on its end, and sometimes the paper would even stick to the balloon. So it appears that electrical forces can act at a distance. So why doesn't the balloon jump towards the piece of paper? Well, although the balloon is light, it is much heavier than the pieces of paper. Plus, I was holding it. Otherwise, you would have seen that even though the balloon was attracting the paper was also attracting the balloon. It's just that it's so much heavier, and I was holding it in place. So, if you open up your books to page 15, and it says at the top, you learned that all contact forces come in pairs. Before you begin, think about this. Do forces that act at a distance come in pairs as well? Can you give an example as evidence to support your idea? So when we were talking about contact forces, remember when you were sitting on your chair, you were pushing down on your chair is pushing back on you. Now, do forces that act at a distance also come in pairs? So go ahead, yes or no, and then see if you can come up with an example. So go ahead and pause the video while you do this. All right, so now you have that done. So if you look at the bottom of the page, it says your teacher will give you and your partner a pair of magnets. Experiment with them for a while and try to figure out the answers to the following questions. Now, unfortunately, you're not here, so you don't have a pair of magnets. So do you have any magnets at home? If so, try and complete this assignment. If not, you can get online, you can Google it, you can Google magnets, and you can see what magnets do, and then answer questions 1 through 4. Go ahead, pause the video and complete questions 1 through 4. All right, now that you've completed questions 1 through 4, you are going to be working on the back side. Now, the very first question on page 16 is, what type of force keeps atoms together in a molecule? So we haven't talked about that yet. So let's just spend a couple minutes looking at this. So here's a molecule. And this molecule is made up of 1 carbon atom combined or bonded with 2 oxygen atoms. So it's CO2, carbon dioxide. So what does it mean for atoms to be bonded? What holds them together? Well, in a covalent bond, they actually share electrons. So the oxygen atoms is actually sharing electrons with the carbon, and the carbon is sharing its electrons with the oxygen. So think of carbon dioxide molecules as a system with three components and interactions between them. These interactions are forces. The forces between the atoms are electrical forces, and that's what keeps these molecules together. So, do atoms actually touch each other, or do they actually get close enough to be attracted? Well, the models of the CO2 that you see up here, these molecules are shown and they actually don't touch each other. So they get very close to touching each other, but they don't actually touch each other. It's the electrical forces that actually act at a distance that keep them bonded together. So they don't have to be a contact force. So can we conclude that electrical forces act in pairs in the following way? Yeah. So the oxygen is going to attract the carbon, and carbon is going to attract the oxygen. So here's a different way of looking at it. So here we have nitrogens. This would be 2 nitrogens. It's got the protons, it's got the electrons. So we could also look at it here. And so here is your carbon dioxide down below here. So again, the electrons is what's holding it together. So now go ahead and answer question 1 on page 16. And then go ahead and answer questions 2, 3, and 4 as well. Now, when you get to number 5, 5 says add to the model of the vehicles all the forces that act at a distance. Now, you notice these lines are at a different spot here than the one on page 16 in your book. That's because they're in the wrong spot. So if your book is an older version, these may be down here. You're going to have to slide them up here. So go ahead and use a dashed line to represent forces that act at a distance. Now that you've completed that, let's summarize what happened. So do gravitational forces come in pairs? Absolutely. So what forces make the moon go around the Earth? Well, it's gravity that makes the moon go around the Earth. Does the moon also pull on the Earth? Absolutely. Think about it. We have these things called tides. Tides are an example of the moon's gravitational pull on the Earth. So we know the moon does impact the Earth. But why don't we feel the gravitational force of the moon? Well, the reason is that our bodies do not feel the gravity is because the moon is much farther away from the Earth than the Earth. So its pull is much weaker, just as the magnetic pull or push got weaker as it got further and further apart. So even though the Earth tugs on the moon tugs on the Earth, and it's equal and opposite, but then we have to start looking at the mass, and because it's so far away and the Earth has such a large mass, we feel the gravitational force of the Earth and not the moon. All right, so similarly, the reason the moon goes around the Earth rather than the Earth around the moon is that the Earth's mass is much greater, which I just said. Although the moon pulls the Earth as the Earth pulls the moon, only the moon revolves about the other because it is much lighter than the other. And the last thing I want to do is be able to add a couple scientific principles. So add these to your book. Every 2 objects that touch apply a contact force to each other. And all forces always come in pairs in opposite directions. So again, once you get done with this activity, let your teacher know that you finished the activity. Make sure you let your teacher know if you have any questions. So that way when it comes time for the test, you'll know exactly what everything is, and you won't get anything wrong in a test because you didn't know it. So again, be sure to ask questions if you have them. Thanks.